Welcome back. We're going to continue a discussion on reactions of aldehydes and ketones, and we're moving just down the chain for nucleophilic addition reactions, and we're going to look at imine formation. Again, I don't want to go into the mechanism, but I will give you a shorthand version of the mechanism. Again, same exact reactants, aldehydes and the ketone, and again a generic amine. This is a primary amine, okay, just like primary carbons. Okay, primary amine is, okay, nitrogen with 2 hydrogens. Secondary amine is nitrogen with 1 hydrogen. Tertiary amine is nitrogen with no hydrogen, and there is something called a quaternary. I hope I spelled it right, and even if I did it wrong, I don't care because I'm not an English teacher. So quaternary amine is a nitrogen with a plus charge. Well, imagine in all these cases, nitrogen has 3 bonds. Whether it has 1 hydrogen or not, it has 3 bonds. But this is a special case. A quaternary amine is nitrogen has a 4 bond situation, but again, the plus charge is kind of the savior there to allow that 4 bond formation. Okay, so primary amine is nitrogen with 2 hydrogens. Secondary amine is nitrogen with 1 hydrogen. Tertiary amine is nitrogen with 0 hydrogen. A quaternary amine is nitrogen with 4 bonds, obviously no hydrogens as well. If tertiary doesn't have any hydrogen, quaternary should not magically have an hydrogen. That also has no hydrogen, and it's a plus charge. All right, and now this is very, very simple. All you're doing is your R can be anything. I've said this like a zillion times now. R can be a CH3 or CH3CH2 or CH3 CH2 CH2. So what if it was CH3 CH2 CH2 and H2? Okay, if this was what reacting with this aldehyde, again, we're focusing only on the carbon containing the double bond O. The rest of it does not matter. Okay, what really happens here is you have your double bond O, right, the carbon, and then you have your H2. Just, we're flipping the order of the amine, writing it in this order. Why? Because the H2 from the amine reacts with the O from the carbonyl, resulting in an elimination of water. So essentially what we're doing is we're writing C double bond N CH2 CH2 CH3. So in this context, all you're going to do is attach the nitrogen in place of the oxygen. Okay, that's all. So basically we're losing water, and this is exactly the same type of process that happens when an amide bond is formed between 2 amino acids, resulting in a protein chain. Okay, so C double bond N, all you have to do is just get rid of the hydrogen here, write nitrogen, and write the rest of the molecule. Now, for some of you, if you want me to do this in the dot structure, so 1, 2, 3, this is 3 nitrogen and NH2, right? It's the same thing in line structure. So it's the same thing. The rest of the molecule is the same, right? This is where your double bond is. Basically, you've got to get rid of the nitrogen, the hydrogen here, and just replace the O with the nitrogen, and then write the rest of the structure. Keep in mind, don't add too many dots. 1, 2, and 3. People have a tendency to add too many dots. Okay, this is exactly the same thing. All you're doing is getting rid of the hydrogen, replace the O with this whole portion, which means you start with the nitrogen and write it backwards. Okay, and that's how you do it. Do it for the ketone, and then this is called an imine. Okay, I'm not writing the actual name, but this sort of formation is known as an imine. Okay, a C double bond N is known as an imine. A Wolff questionnaire, this is probably something you probably would like and probably want the entire test to be filled with the same question. This is called a hydrazine. This is a very, very unique molecule. Okay, it's called hydrazine. Okay, it's been tried as a rocket fuel, as a component of a rocket fuel, because it's self-igniting and doesn't need a lot of heat and produces a lot of heat. So hydrazine, all you have to do is replace, okay, basically it replaces this, right? We had with an aldehyde, we already had a hydrogen. I'm going to draw this for measure. Just replace the double bond O with 2 more hydrogens. Okay, basically you are going from a C double bond O to a CH3, okay, for an aldehyde. With a ketone, all you're going to do is replace the double bond O with, so basically you're always replacing the double bond O with 2 hydrogens, okay? 2 individual hydrogens, okay? So same thing here, replace the double bond O with 2 hydrogens. Basically you're going from an aldehyde to an alkane, aldehyde to an alkane, and a ketone to an alkane. Okay, same thing. This is Wolff-Kirchner. This is indicated by the hydrazine. And then there's Clemenson, which is again the same thing, just like what we did earlier. Replace the double bond O with 2 hydrogens. Okay, so it doesn't matter whether it's an aldehyde or ketone. This is an aldehyde, of course. So write most part of the molecule the same. When you get to the carbon containing the double bond O, replace the double bond O with 2 hydrogens. Keep in mind with an aldehyde, there's already a hydrogen there, so that's there. This is what we have added, okay? And this is a ketone. Now Clemenson is indicated by zinc mercury amalgam. It's easier to remember. Again, with a ketone, replace the 2 double bond O with the hydrogen, and that's, so either of these cases, an aldehyde is going to an alkane, and ketone is also going to an alkane. I think I'm going to wrap this one here. I got one more video to finish up the synthesis because I think I might be at 8 minutes now. So I'll stop right here. I'll see you back with one more video.